Level Up. Tonight, our co-founder Dimitri, who is the usual guy who's in charge of the audio-visual stuff, can't be here. So you're left with Guillaume and myself, Rory. We're going to try our best. So if things go terribly wrong, then please bear with us. But okay, I'd like to introduce our first speaker for this evening. Peter's been a member of the group for a few months now, and whenever he comes to one of the meetups or whenever we speak with him, he's obviously a guy with a huge amount of experience, and it's incredible that he's actually showed me a few different talks that he might have given today, which were equally as insanely, detailed and vivid. So, look, it gives me a huge amount of pleasure to welcome to the stage Peter, who's going to be talking to us about scaling.
Yeah, I thought that scaling is a well-discussed topic, and I had the impression that people associate scaling with Kubernetes primarily and containers secondarily. So when I dug into the whole topic a little bit deeper, I realized it's a lot more complex, and Kubernetes is a solution, and if you are Google and have 10 billion web requests per day, then it's probably the only solution. But when I looked around the study group and when I looked at the startups, I thought 10 billion views a day will be like trying to reach Mars on a spaceship. It's a goal and it's a worthy goal, but in reality, for most people, it's probably not on the agenda for the next 5 years. However, I thought it would be interesting to discuss the whole scaling topic. I started this company, or I am in the process of starting this company. The purpose of the company is to create tool sets for growth companies. So scaling would be interesting for them because as a growth company, you expect it to be scaled. My professional experience has been, I started as an applied physicist in semiconductors, and I moved to Wall Street, worked there for 30 years. And actually in the pandemic, I sort of went back to my roots and started to program with Golang, and actually really liked Golang. And Golang is the language Google basically sponsored in order to facilitate their scaling. So I started building software with that. I already talked about some of these topics, but essentially scaling is necessary. I mean, you have to think through scaling if you have an app or you build any application over time. It's just, and scaling, as I said before, doesn't necessarily involve Kubernetes. So to illustrate this in a more humorous way, you probably wouldn't use a semi-truck to delivery in a local city. And just like scaling, there are a lot of options how to get your software to cover 10,000 users, 100,000 users, or 1 million users. And as you see with this truck, which got stuck, sometimes shooting for the moon is not necessarily the way to achieve results, certainly not quickly. So just from a sort of overview point of view, if you scale, there are really sort of 3 avenues can pursue, and they're not mutually exclusive. One of them is hardware scaling. I mean, and I'm not going to get into details, but clearly every year the race, it used to be the race of what company made more faster gigabytes, but now it's sort of leveled off at 4 gigabytes per second, and the current scaling in hardware is more cores. So clearly, and Alibaba has developed a ARM chip which has 256 cores, and there are there are cloud companies, bare metal server companies. You can rent this for 250 euros a month. The second is horizontal scaling, where you just use more computers, but you can use more virtual instances. And then the third one, which people like to avoid because it's timely and costly, but it sometimes is very effective, is software optimization. In this talk, I'm really going to focus more on horizontal scaling. Initially, I presented the talk to Rory, and it was too long for this meeting. So I cut it back down to one topic. The key in scaling is going to be to find out where your bottlenecks are. And there are some tools available basically on tracing and testing to determine that. And then you can make more intelligent decision what part of the software and hardware needs to be beefed up. So starting from a very simple picture where everybody, I guess 20 years ago started, you have a number of clients, that connect to a server. But as the clients grow, your user experience shouldn't suffer. I mean, Google has made this famous statement that if your response time is more than a second, you're probably going to lose your client. And so the key is, as you scale up, to still give the user the experience like he's the only user or one of 10 users to your server. And we had a talk before about the 1 second checkout. It all echoes the same sort of theme. You need to be super responsive. Here's just a little overview which stayed in the slides. The easiest approach to scaling in the beginning is just you can go from an instance of 2 vertical CPUs. There are 100 cloud providers which will gladly rent your DigitalOcean, Linode, and et cetera, to Amazon, to Google. You can go from 2V instances to 4 instances, 16 instances. Ever since last year, I think AWS and Amazon and Google have now tried to sell this by second of compute time, which is a bit dangerous because your bill can be enormous. All these virtual CPUs, they really run on hardware, and your typical hardware now starts with a 6-core machine, which is really 12 cores because they have 2 logical threads. And AMD, I think right now it goes up to 64 cores, but which would be 128 logical cores. And soon they're going to be doubling that. And as I said before, Alibaba already is offering a 256 core, albeit an ARM slower speed performance. So clearly that's on the beginning the cheapest solution to scale up. The horizontal scaling, which means you want to use for redundancy and also more scaling, is the graph shows it better, but you basically, the initial step would be a load balancer where you divide the traffic, and if you have simple static websites, that's very easy. You can add as many servers as you want, and the load balancers, all the letters, the login people with the letter A get server 1, and the people with letter B get server 2, and you can scale that to infinity. The other thing you can do is obviously content delivery networks, which are the number of companies, Akamai, Cloudflare, blah, blah, blah. And they have servers all over the internet, and at least part of your static delivery can reside on that edge server, and you will get much better performance. You can also cluster these, if your application runs in a container, which is the alternative to a virtual instance, you can cluster your containers into a pod, and then Kubernetes is just simply the control software which initiates and controls the containers. And there are people who offer managed Kubernetes services now. And you can even go one step further. There's a company called HashiCorp, which has software called Terraform, because most cloud providers, at least the ones who intend to stay in business for the next 5 years, they now offer an API, and the API allows you to spin up an instance and create it through a program. And what Terraform does is it kind of create a shim. So because every API is, of course, slightly different. So there's a sort of translation layer where you can, actually they developed a language, but you can you can sort of, it's abstracted, so you can simply tell, create another instance. And if the instance happened to be on Google, or it happened to be on Contabo, or it happens to be on Linode, it will translate it into the specific commands for the specific API which Linode or Google or Amazon has. No, sorry. So this is meant to be illustrating the content servers, which would store 80%, 70% of a typical website it contains of images. So a content delivery network is a good place to store these images, so to get fast response time. Over the last 10 years, this virtualization has become a big topic, and I guess I'm trying to go into detail what how you get from the hardware, from a bare metal server to a virtual server. And really, it was actually introduced in Linux, I think, with version 2.4. So it's really pretty old. I think 2.0 was like 2000. And what it was introduced in Linux is really isolation of namespaces. So if you have application A, you want to make sure that some hacker doesn't find a backdoor to application B. And most obvious is a lot of the WordPress sites, they use one common PHP interpreter, and then you can put a system call in PHP, and suddenly you can check out all the other websites. And if you're malicious, take them down. So virtualization was really the initial reason was really to create namespaces for insulation. Now, as these computers over the last, I would say the hardware over the last particularly 5 years really grew in cores, the problem the hardware manufacturers have, well, I can reduce the cost per whatever CPU second with more cores, but most programs aren't written in concurrent language. Most programs are still, single-threaded and one instruction at a time. And having 64 cores, 63 cores would be sitting idle, and maybe one is doing an operating system background check, but how do you take advantage of this power? Well, here comes in virtualization, where you literally create a sort of virtual computer on top of the hardware. So typically, one virtual CPU is one core, or two vCPUs is one core because of two logical threads. So suddenly, you can take the cake and divide it up, and you can offer a slice for $5 a month to you, and another slice for $5 to you. And so with the 64 core computer, you suddenly can get 32 times 5, which is you can. So for the data center providers, this was a huge plus, and for users or people who have large application programs, it also provided this additional layer of safety, because there are these namespace isolation. There's the 3-4. It has every namespace. With virtualization is even better than Docker, because you don't even share the operating system. So you can run Windows on virtual CPU number one. You can run different versions of Linux in each one of them. So Ubuntu on Virtual Server 2 and Fedora on version 3 and so on. This is just a quick overview. There are different versions, but currently you still run typically Linux, although Microsoft has also a hypervisor. So you typically run a Linux system on the bare metal, which it takes about 5% time, but on top of that there is, if you virtualize, there is a hypervisor. There are two programs. They've been in existence for 10 years, KVM and XN, and on top of them then you run the virtual server. So that's the architecture, which I think is helpful to know, at least in your head when you think about building these bigger systems. So as I said before, now I'm repeating myself, but it's really now, I think more than anything else, it's about namespace separation. So the idea is that process 1 cannot have access to any resources of process 2 and vice versa. If you want two virtual systems or two containers to talk to each other, it's like talking to a different machine, and you have to go through TCP, you have to go through UDP, you have to go through sockets. The other advantage is you can is claimed that dividing the pieces up into little pieces, the little pieces are easier to maintain. There's a famous book, actually it was the first book they made us read in a class at MIT, which was The Mythical Man Hour. And I recommend everybody who wants to do scaling to get that book. And that book actually talks about IBM's voyage to create an operating system for the IBM 360. And they tried, so first they fell behind. So what do? Hire more people. Well, when you hire more people, you've got to train them first. So they fell further behind. And the book just goes through, and then they decided there are too many people, there are too many meetings, so we need to divide them up into different departments. So then things got lost in between. It's a book worthwhile reading. It's a classic. So with virtualization, you kind of create, like in a ship, you have walls. So if there's a hole in the hull, the ship doesn't sink. The walls in between ensure that only one compartment is underwater. That's the idea of virtualization. Now Kubernetes, I'm not going to go any more, but it's a rather involved topic and would be a whole separate, at least one talk, maybe two talks. I put this diagram here to show that it's actually a relatively complex topic. Now I'm jumping here a little bit, but so when you build the system and you scale and you have multiple virtual servers and maybe load balancers and maybe you have microservices, that's another way to scale because you can offload certain things to other servers. It becomes confusing. And one of the biggest time lag there's latency and throughput, right? Latency is the delay when you hit a key until something comes back. Throughput is how many bits can you push through the pipeline at a given moment. So TV is needs a lot of throughput, but you don't care about latency so much because you just watch what's on the screen. You don't really care when it originated. When on the other hand you have a phone conversation or a Zoom, you care about latency because you don't want there to be a pause when you say something until the other person heard it. So one of the interesting things is, right now, even in the fastest system, those are typical numbers you're going to encounter. I haven't seen a machine where the TLS handshake, everybody needs security. Does everybody know what TLS is? I hope, yeah, transport layer security. But to exchange the keys, that takes 300 milliseconds. Maybe there's some magic to get it down to less. And there's been talk to move part of the TLS into the kernel to make it faster. But that's a penalty already. So when you have your budget of 1 second and you first log in, so 300 milliseconds is already basically lost. When you typically, your browser will ask for index.html or whatever your landing page is. But it also automatically, as I found out the hard way, will also ask as the next step for the favicon. Now you can sidestep that, and this goes into the software optimization by when you, as part of the index file, you can download the favicon as a CD or as a byte file. Then you're avoiding one round trip before anything happens. And then typically you have some script which also has to be downloaded, right? And that's 100 milliseconds. And then, of course, if you have 10 pictures, if you do them sequentially, it's 10 times 100 milliseconds. If you do them in parallel, you know, there's all the tricks of front-end computing. If you do it asynchronously, lazy load and so on, you can do it in parallel. Now, I think a lot of systems rely on a database. So all this optimization is great, but typically you still only have one database server in the back, which then becomes the bottleneck. If you use multiple database servers, you're going to lose the atomicity of the data if you have to wait, if you don't wait until all the slaves have been updated. So, you know, with your, even if you preload the connection, every write operation, you're going to add another 100, 200 milliseconds because your slave needs to get the control and acknowledge it before you can deliver something back to a client to make sure it's correct. Lately, I've seen, I've always worked with Postgres, and I think lost Google I/O's announcement, and I'm not here party. Amazon did the same thing, and Microsoft actually also. Microsoft has bought a company called Cetus, and anyway, they optimized Postgres by changing the storage engine in the background. So rather than having sort of a file system, they use they use a different storage system. And there's a company, another startup, who kind of illustrated very well what you can achieve. And this goes a little bit into software optimization. This would be plain Postgres. You can do 200 transactions per second. With a different storage system, they were able to scale it up to 800,000. Same hardware. So that's a ×4 benefit. Yeah, we talked about. I talked already a little bit about scaling with microservices. I mean, one of the other approaches, offload certain common things to different servers. The advantage is you can always bring in more. The cons is, at some point, with too many microservices, it becomes a very confusing spaghetti world. And you won't know what exactly caused things to slow down. So my recipe for scaling is, I think, it would be to first create your objectives. I mean, do you care, is throughput important, or client response time? And then just sort of roughly map it out, what your expectation would be as an architect or software architect or programmer, what your expected results should be. If they're within a reasonable percentage, then you're probably done in the software optimization. But if they're really different than your expectation is, I think then I think it's time to get to work. And the key here is to find the bottlenecks in the system. Sorry, I'm going backwards instead of forwards. And fix those bottlenecks and then see whether it's better. Probably won't be as the next bottleneck. Now there are some good toolkits for this. Like I said, on vertical scaling, you can always get a bigger, all these database cloud companies, they're happy to sell you a bigger service on a bigger server. In Horde, we talked about load balancers, Kubernetes. You can optimize your network connections. I think there's a slide. Yeah, I mean, I'm sorry, I should have put it somewhere else, but just HTTP 3, which still most people use for REST services, or even, going from HTTP 1 to 2 to HTTP 3, which is UDP basis, you pick up quite a bit of speed. You can, the first obvious easy step is to look at the waterfall in the Chrome browser and see what takes long to load. The second, which is harder, is tracing. And there's tracing on a single machine, and there's tracing on a distributed basis. And that's what I was meant to show earlier, the spaghetti arrangement of different microservices. How do you know which one, where is the holdup, or some of the holdup, or most of the holdup? So there's a couple of new technologies now. eBPF, which is Berkeley packet filters extended, and what that is it's a C program. It's a special C program which you can load into the kernel, which will run in the kernel, and you can attach probes, so you know when a process starts, when a packet comes in, or anything which happens in the kernel, which up to now was a black box. There's a way to get this and put it in a map where you can then look at it in user space. I already showed you how you can optimize it. It's not a minor thing. Going just simple things like changing the HTTP protocol, just going from HTTP1 to HTTP2, and only 5% of all websites currently use HTTP2, and other than Google and Cloudflare, nobody uses HTTP3. It's not even approved yet, but it does work in the Chrome browser. HTTP3 is implemented in the Chrome browser. For microservices, we had this talk about REST APIs versus gRPC. You get a significant pickup going to gRPC. gRPC is basically the data are transferred in a binary manner, and it uses HTTP2. In HTTP2, your interleave, so you can use one physical connection, but you can have several data streams, and they get interleaved. If you don't know how HTTP2 works, they get interleaved. So you can, on a one physical connection, you have on one packet you transmit, so you have a physical connection, then you transmit a packet, and within the packet, data frame 1 can be request 1, data frame 2 can be from the same or can be from a different data request, so you kind of interleave it and move it forward to the server. And then there is this other tool called Flame Graphs, which actually takes your tracing data and visually shows you visually where your holdup is. And I think it's quite useful. It's a bit more complex than I can even go into in this talk, so I'm just leaving you with this yellow and orange graph. So I think my conclusion was, and I hope to be able to transmit that, scaling is not a simple, there's one solution. Oh, let's go to Docker and Kubernetes and we can scale to infinity. Really, no. It really takes some engineering. And engineering is always, I was a physicist, it's taking the physical laws and trying to optimize, and that means finding horses for courses, which is a great impression in English, meaning you need to find the right approach for your particular project. And there is no generic solution. There's not a simple, oh, let's go in a drawer and pull out the scaling book. And really effective scaling, it requires a plan. You have to define your objectives. You have to measure yourselves against these objectives. And some of the inputs, which I just put random, not random, but a number of examples, really. They're not meant to be a full representation, but they're just a number. It's the number of clients you intend to serve. Probably not Google. You probably don't need to serve 1 billion clients, but maybe if you have a startup, maybe 10,000 clients. And for that, you try to get a solution to serve the 10,000 clients efficiently. The planned response time, I tend to think that you want to be under the 1 second, meet the 1 second rule. You can use microservices. They seem to be the latest great advertising, but be careful of the spaghetti, which might be generated by using too many microservices. And maybe it's better to have a little bit more complex app instead of dividing everything into a little piece. Then, of course, if you use a database, which most people use, and you want atomicity, data integrity, then you have to really look. That's a whole different topic, looking at the database arrangement. I mean, there are things like sharding and, okay, I won't go into it because there's another, would be another 40 minutes. And then the final topic is, apart from being able to serve all the users, there is, the topic of reliability, which I didn't really get into, but you certainly want to be able to serve your users 24/7, and for that you need some redundancy. And that's really, I want to share my thoughts here on scalability and the options a system architect has.
Incredible, thanks so much. There were so many details there, virtualization, load balancing, we got right into the kernel as well.
So
Okay, so
there must be some questions. I can't imagine that there wouldn't be any questions.
So, yeah, any questions? Who'd like to go first?
Are the slides available online, or is there a link?
I can make them available, yeah.
Okay, I'll share the slides in the Telegram group, and
We can make a PDF and yeah.
I'll share a PDF. Yes.
What's the biggest scaling success that you've seen? Like you applied what you've said, try to observe using tracing and other techniques like that, and then you've seen a clear bottleneck, and then you've been able to solve it. Do you have any kind of do you have a story?
Well, right now, this was the other talk actually. The first thing I did is I actually wrote, instead of React, I wrote my own JavaScript library and built the DOM without a virtual DOM. And I saw, at least on my setup at home, and now I just leased a offline system to see, but I got 500 milliseconds response time to go from a canned framework to using my own framework, because it's just pure JavaScript, and I don't even use HTML. My index file is 7 lines of code. It's basically doc HTML script and body and script and then I pull in the script, and the script builds the whole website. And yeah, I saw that alone doubled the performance.
Is your JavaScript framework in a condition to share yet? Is it ready?
I was gonna add some more improvements before I share it, because the parameterization, so you can put templates. I don't have templates right now. I have states, but not templates. But and I also think I can make it faster by building a bundler, so that not the entire library gets downloaded. But again, here in Valencia, we're really spoiled here. There with internet connections. I mean, I lived in New York, I lived in London, and it was getting a megabyte was like, oh, thank goodness. And here, my connection is 600 megabits, so what do I get? Downloading 100. There's another trick you can use is when you create a TCP connection, there's a throttling initially to test the connection. You can undo that. So that way, instead of starting to transmit at 50K, you would immediately go full speed, which with the current sort of fiber technology in the world, there's a lot of overhead from years past, which is still carried around. And people just the infrastructure just is very slow to shed this overhead.
Over here, yeah.
I would just say, like, in terms of like work culture, do you prefer to wait until the business side asks you to make it faster, or do you go and say, hey, this is too effing slow, we need to make it faster?
Well, okay, it depends on how you market yourself. Generally, I think I prefer to be on the front, and that would be one of my objectives, right? I mean, and there are two things I believe in sales is like, what's your one thing? And the second one, you need to rise above the sea of sameness. Paul Lindstrom, read the books. It's so clearly I want to rise above the sea of sameness, and not in a discernible, clear manner. So there's no. It has to be obvious to people, otherwise they won't pay for it. I mean, see, the first approach is, if you talk about business, is, if you go to market something to the IT people, they always find something better and great, and they will always poo-poo it. So there's no point. I worked as a long time as an investment banker, so you just go to the CEO, and CEOs have to make the decisions, and they are usually not software programmers. So you want to give them something which they can relate to and see a direct benefit. And if you can't communicate that, I don't think you can ever have a successful business.
Okay. Any other questions?
As you touched on, the proximity to your customers is kind of key, because you reduce the latency with it being physically close to your customers.
Right.
So between central physical location and optimizing the latency using a CDN, like you said,
Right.
or dividing and spreading your infrastructure regionally, what's your favorite strategy?
Well, like I said, it depends on what you're delivering and what you do. I mean, right now I'm more focused on ERPs. There aren't that many pictures, so then I don't really need CDN so much. If you deliver a lot of pictures and a lot of static stuff, then I would definitely go with CDNs. I mean, if you have a website like Booking.com, or you want something where there are a lot of pictures and people want to see them, go to content delivery networks. Pictures are, websites with many pictures are 80% of the total experience. So, and then you can use tricks like start with low resolution picture maybe, and then in the meantime download a higher resolution picture. There are a million tricks to make that go faster. But if you do more like a bank and accounting systems, or where you're really pushing data back and forth, IoT or something, don't see how content delivery, they help you maybe with your JavaScript, not that much. Download the JavaScript library, but one topic I didn't go into is what I just discovered was DNS. DNS lookup is really slow for most. I mean, if you use your normal like Vodafone, it's like 60 milliseconds. Cloudflare has the fastest 9 milliseconds. So and they use 1.1.1. So Google is like 30, and every time if you build an email server or you trying to connect to if you use names instead of maintain a DNS cache, that's the first solution. But if you're trying to connect to your microservice and you have to look up the name, and you have a complicated structure and you do 100 DNS lookups, there's 100 times 30 milliseconds of big time.
Okay, one final question.
3 favorite books.
3 favorite books. Oh.
Favorite books in computer science, I presume, right?
Only 3.
Pardon?
Only 3.
Yeah, in computers.
Yes.
Because I have other favorite books like The Silk Road is highly commendable. Well, I think one of favorite, but what's instructive is definitely the book I mentioned, The Mythical Man Month, because it kind of highlights. I like, there's a book, it's also pretty old, The Soul of a Machine, which people built this Data General, which used to be a competitor of Digital Equipment Corporation. Yeah, I mean the other ones are, I don't even know. I think actually some of the MIT has this OCW, the online courseware, and I actually went back and revisited. I mean, I went to MIT, so I remember those classes, and actually I got a lot out of it taking like the artificial intelligence class by Patrick. He's dead now, but he passed away, I should say. But that 6034 class is really helpful. It goes, today it's called algorithms, but it really goes through, it really explains a lot of things. Now he poo-pooed machine learning, I mean, but he gave this big explanation, but goes through, search methods and Dijkstra's algorithm, and so that's really helpful. I give you 2 other books which I just not have read yet, but I downloaded. One is how to build a compiler in Go and an interpreter in Go. I think that's, and final thing is, there's a programmer called Dan Bernstein. He invented Salt and Qmail, and he's really a cryptographer. And his papers, there's no book, but on his website there is a list of his papers. So if you're really a little bit of a math nerd, I think he is, he's a real genius. I mean, he's really, I programmed CDB. I mean, I just looked at Poly 1035 and Cha-Cha-Cha, these crypto algorithms. I think there's a world to learn from him.
Amazing. Okay, thank you very much. Okay, everyone, on the table behind you over there, we have some snacks. There are drinks on the table.